I'm Russ from Invisitrack. So what we're going to talk today about is location using LTE. And as Dave from CSR pointed out, we're used to GPS and having that functionality available to us. And when we go indoors, it's significantly harder to have the same experience. And there's been a lot of work done by companies like CSR that's quite good to provide location. But our position is that LTE will offer a critical component for location. I'll give you a ubiquitous indoor-outdoor experience. So LTE is growing, and by the end of this year, you're going to have 209 commercial deployments in 75 countries. So that means you're going to have wide coverage that will allow you to traverse from indoors, outdoors, or wherever you want to go. The other advantage of LTE is it makes for a phenomenal ranging beacon. So it is significantly better than, let's say, GSM or CDMA or Wi-Fi or Bluetooth. So as a signal itself, it's able to do a lot more things than what's been traditionally thought possible. So what do? Well, our core IP deals with multipath. And again, as Dave pointed out, you go indoors and things get really messy really fast. And what we've proven and what we've developed is a completely unique way with dealing with the effect multipath has on the signal. In addition, cellular is slightly different in terms of what type of environment you're in. You have a lot of noise, you have a lot of devices operating the same frequency, and we actually turn that to our advantage. In addition, we developed some signal processing gain within the LTE signal. So for example, what you consider LTE availability for voice or data, well, for location, you have twice the range. So in my mind, the way I think about it is using LTE for location gives you the best total solution where you have good range, accuracy, and reliability. And again, since you're just using the LTE modem and nothing else in that particular scenario, it's very power effective. So you have significant reduction of power consumption in many of the applications. So just a background, we have been around for a little bit of time. We have our first LTE M2M module coming out in Q2 of this year. We have quite a bit of IP issued in the US and throughout the world dealing with LTE location and multipath mitigation. And we've shown sub-3 meter accuracy in small cell deployments in live LTE networks. So this is just kind of a high-level overview of what we do. So within the LTE signal, there are carrier signals that are available, so they're always there, they're always present. So we take those carrier signals. What we're able to do is to find the relative position of the device or the phone to the infrastructure. And from that, we're able to map that on a map, either using Google Maps, and again, you have the indoor location mapping evolving, so that certainly will help. What I want to focus on briefly is the power of having a cellular solution. So for example, the macro LTE base station has about 1 kilowatt of ERP. So it pretty much lights up the whole freaking world around it. And especially in many countries, you have LTE being available lower frequencies than, let's say, Wi-Fi or ultra-wideband. You have very good natural penetration and propagation. So how does that translate to the real world? Well, this is just, so we took like a little software-defined radio into San Francisco and just did some signal captures. And so what this shows you is in below ground parking, you could see a whole constellation of macro cells. Same is true when you have in this case was department store on the 5th floor. So what we're seeing typically is in an urban environment, you're able to see macro towers between 3 and 8 kilometers away. And in suburban environments, you have as far as 15 kilometers away. So what that gives you is it gives you ubiquitous coverage as LTE is being deployed that you can start finding the location devices with. Now, in some situations, you want to have reliability, and you want to have, and where LTE isn't that robust or fully deployed. So the advantages that you gain with LTE small cells, and we feel small cells will play a critical component in this, is that they provide a much wider coverage area than Wi-Fi access points or ultra-wideband solutions. So what that translates to is, in this case, you have a 150,000 square foot warehouse. You would need a fraction of the infrastructure to cover the same area. And in locations where you have macro cells that are present, now you can start reusing that particular infrastructure and further reduce the amount of infrastructure that needs to be deployed to get ubiquitous coverage. What we'll demo today is we have some testing that we did, so just walkthroughs, in the San Jose airport, where we're just showing the location of the device relative to the macro infrastructure. And we also did a drive test around the airport. And right now, this is still early stages of LTE. We're showing about a 15, 20 meter accuracy. And as we move from release 8 to release 9 for 3GPP, there are other things going to come into play that are going to further enhance that resolution. And so why does it matter? And I think, again, Dave pointed out, there's M2M, public safety, consumer, all the typical things that people talk about. I'm just going to quickly hit upon two. Before I do, the one thing I want to say is the way this will be ultimately presented to the network is it'll just be another API call, right? So you have API calls for Wi-Fi, you have API calls for eCell ID, and this will just be another way of accessing it. So it'll be available to all the market vertices, to all the developers. It's just one more added functionality. So with mobile couponing, there are very good solutions for malls for using Wi-Fi and MEMS and dead reckoning, and they're absolutely valid. There are situations where you don't have the Wi-Fi density to get that type of resolution. So in those situations, we feel that an LTE-based solution will be the most economical, accurate, and easy to deploy. So with M2M is the other piece I want to cover. And now we're starting to see quite a bit of demand build up for M2M products. And this just points out that by the end of the decade, it may be just as big as the whole consumer phone business. Where I think it gets interesting is that when you look at why people use or want to have M2M type of devices, location is either on the forefront or in the top three really kind of functionality that they're looking for. And so our thought is that over the next couple of years, what you're going to have happen is you're going to have the LTE modems come down in price. So you wind up getting a single mode LTE modem that will be just as expensive, or probably even, probably on the order of a 3G M2M module. So it'll just have the modem by itself and nothing else. So it'll be very low cost, high accuracy, so much better accuracy than you're getting with 2G and 3G M2M modules. So we feel that the transition to LTE-based M2M modules is going to happen much faster than people anticipate. So in summary, the way I think about it is that what LTE offers you is the ability to have really good granularity, let's say in a warehouse. So you want to have 3 meter accuracy, you put a couple small cells in. But once that, let's say it's a package that's being tracked, once it's thrown in the truck, even though the truck is somewhat of a metal box which precludes GPS from being able to reach it, LTE is a powerful enough signal and, at very good frequencies that'll let you track it. Then even if you start, once the package is delivered or has to go somewhere else, even if you don't have the small cells helping you, you still can get very good and accurate location of that package just without any infrastructure present whatsoever. So we have a demo showing it working in the macro environment. So if you want to come over and ask questions, we'll be happy to answer them. Thank you.